Hey, my name is Watson. I did the Sudoku solver portion of the project. I'm just going to go over what I did. So for my algorithm, I did backtracking, brute force with addition to backtracking with constraints. For I'm just going to ignore this function first. This is just to import my Sudoku board. But for the main functions, I have the constraint checks. So checking the row, the column, and the 9-square block, checking if any of those constraints are violated. It's just looping through the positions of each row and column and seeing if that value already exists. Um, for uh, for the constraints, I have this other function here just for legibility. It's just checking if any of those constraints are violated. Uh, if they aren't, then we return true. For the main function here, I pass in the current board state, the current row, current column, and the metrics. Metrics here is a dictionary, and the row and column are integers. This line of code is just checking if we already looped through all the positions of the board. So 0, 0 for my board starts at the top left, and then it goes column by column, and then row by row. So top left to bottom right. Here we're just looping, as we're looping through the columns, we're checking if it's already gone through all the column positions. If it is, we go to the next row. Here we're just checking if the current cell we're looking at is empty or not. If not, then we go through this for loop, which is where we try to place each place the values 1 to 9 in ascending order into the current cell that we're looking at. So we check if the constraints are violated, and if they're not, then we place down the current value in the for loop into that position, then go on to the next cell. If we end up in a dead end, then we have to backtrack. Where this line of code comes into play, we just reset the cell to 0, which means empty, and we go through this. We keep going through the for loop. Here, I call the import Sudoku board function, which is to import the Sudoku board. So it takes CSV text files and where white space can be represented as empty cells as well as zeros. I do that up here. I'm using pandas to import the files, and I'm assuming there's no header, and I'm just importing them here as strings while replacing the white space zeros. While going through this logic here, I am trying to convert those files into a nested list to be read, where the outer list is represents a row, while the inner list represents a column. So that's what I do for the rest of this logic here. For the metrics, I have execution time where I take the time before and after, subtract them, round them off, and turn it into milliseconds by multiplying the number by 1,000. For the metrics, I set them as a dictionary. I just pass in this dictionary into the main function where it saves those metrics as it goes through the recursion by returning them as a parameter. For recursion calls, it's just whenever the main function gets called. For stats, it's just whenever we're trying to place a number down within the cell. And backtracks is when we have to reset any cell. We also have this missing values metric where I count before we try to solve the Sudoku board. So I'm just checking the amount of missing values. And I'm just going to run the script. This is what it looks like. We have the solve Sudoku board with the metrics down below.
Hi, I'm Chen Zhang, and this video is for my coursework 1, Lunar Exploration Planning. In this project, I use PDDL to model a simple mission on the moon. The idea is to light a computer plan to plan the rover's actions automatically, like where it should go, what it should do, and how it to finish the mission. The domain design in PDDL, the domain means the rules of the world. It tells what things exist and what actions are possible. In the domain 1, I made 4 tabs: lander, rover, location, and simple. That's all we need. For example, if we don't have the sample, we can show the difference between taking a picture and collecting sample. If we mix lander and the location, we can't store the sample at the lander. So this design is simple, but works well. You can see my code here. And for predicts describe what is true in the world. For example, this line means the rover is at the location, and that one is memory empty, means the rover its memory is empty, and this one, image saved, means the photo from the place is already sent back. And for actions, action describe what the rover can do, like move and take image, scan, pick up sample, so on. Each action has conditions and the results. Conditions and the results. For example, take image. The rover must be deployed and memory empty. After doing it, the rover has an image and the memory become empty, become full. And I also made two small actions. Like I can give you like the pick up simple and transmit image like that. And now let's move on the mission one. Mission one, there is one rover and one lander and five weapons. The rover needs to take one picture, do one scan, and collect one sample. This is basic test for to make sure my domain works correctly. So let's write it on. Yeah, my domain is correct and the mission is success. And let's move on the mission two. Mission two is complex. It's more complex. There are two rovers, two landers, and one way map like that. And each lander can only keep one sample. This mission checks if my model can handle multiple rovers and one-way passes. It also shows that all actions can still work together correctly. And okay. Yeah, we can see here. And now let's move on the mission three, the difficult one. And first, the domain need to be extended. Mission three as astronauts. There are two astronauts, Alice and Bob. The new rules are simple. The rover can only be deployed or store a sample when an astronaut is in the docking bay. Data can only be sent when an astronaut is in the control room. So add two new tabs, astronaut and area. Astronaut, Alice and Bob. Area is docking and control. So that one we can see here. This line means who is in which area. The astronauts act like switches. They don't do the action, but they decide if it can happen or not. It's an easy way to normal text the rules into PDDL logic, and we can run the mission 3. Yeah, success.